Hello everyone, welcome you all to the microcontroller class. Today we will be having session 1 of unit 3 embedded C, and these are the contents of today's discussion. So here in this session we are going to learn how to do programming with C, what are the advantages and the disadvantages of using C program in 8051 microcontroller, what are the various data types supported by 8051, the general structure of C program and some of the sample programs. So coming to the programming with C, we know that programming with C has become popular because of easy programming as compared to the assembly level language programming. C is an example of the middle level language. So we know that in case of C programming, we are going to use English like sentences to write the program. Hence, it is easy for the user or for the developer who is going to write the program. Because of this reason, the program can be easily written with the help of the C code as compared to our assembly language programming. And in some of the textbook, it is mentioned that C is an high level language, whereas C is actually an example of the middle level language, where it can actually act as middle programming between the high level as well as the machine level language. So coming to the advantages of the C programming is less time consuming and easier to write as compared to assembly language programming. The reason for less time consuming is because we are going to use the English like sentences for writing the code. That's why it is easy for the programmer or for the developer to write the code quickly within less amount of time. And C code is portable. Portable indicating that the C program written for a particular microcontroller can be loaded into different microcontroller using cross compiler, whereas this is not possible in case of assembly language programming. So the code written for one type of microcontroller is not compatible with the other microcontroller. Means you cannot run the same code in the other microcontroller. Whereas C is not like that. In case of C, it is portable. The program written for first microcontroller can also be used for the second, that is the different type of microcontroller, possible with the help of cross compiler. We know compiler is a software or compiler is a program which will going to translate the C language into machine level language, because we know that C is a English like sentences and our CPU cannot able to understand this type of language. Therefore, we need to conversion is required. We need to convert this high level language into or the middle level language into machine level language, that is binary zeros and ones. So for that, we are going to use a software called as compiler. And C programs are easier to modify as well as to update. We can easily modify and update the C programs. And also C programming supports library functions like finding the sine, square root, cos, some other exponential. So to calculate these functions, we are directly having some inbuilt functions, and these inbuilt functions can be directly used to whenever we are going to write the code. So this makes the development of the code easy. So library functions can be used while writing C programs. And coming to the disadvantages, it requires compiler for the translation. So this is an additional software which is required, compiler which will going to convert this C program into machine level language. And assembly language programs produce fixed hex files of fixed size. So in the assembly language program, the hex file size is fixed, whereas in case of C programming, different compilers will going to produce the different hex code sizes. Because of this reason, it is difficult to calculate the exact time delay in C programs. So because of this reason, because different compilers will going to produce different hex codes. And C programming produces a hex file that is much larger than the assembly language. So therefore, the size of the C code, which is the hex file means it contains binaries, and binary 0 and binary 1, only zeros and ones it contains. So the hex file produced by the C language, the C program, is much larger as compared to the assembly language programming. And the general purpose registers of 8051, such as R0 to R7, A register B, A is nothing but the accumulator, are under the control of the C compiler, and they are not accessed by the C statement. C statement cannot directly access these registers because they are under the control of the C compiler. Only with the C compiler we can able to access these registers. So these are the some of the disadvantages of C programming. Next is the data types. Data type is a type of data that a variable can hold. So this is the definition of the data type. A type of data that a variable can hold. So these are the different data types supported by C programming. That is unsigned char, signed char, unsigned int, signed int, S bit, where S stands for a single, or it is also called as SFR bit, and a bit as well as the SFR. So these are the different data types supported by 8051 C. So here, first of all, we shall define what do you mean by a data type. So for example, if I take some variable, let the variable be A, I will assign some number to this variable. For example, shall assume that I will assign 14. 14 is the number. So we can say that 14 is an integer number. So therefore, this is a variable. So this can take any value. Now, initially I am assigning 14 to the variable A. Therefore, the number 14 will be stored into the variable A. Now, the number 14 is what type of data? So I know that the number 14 is an integer data. So I can declare it as int. It means that the variable A can hold any integer value, need not be 14. It can be 1, it can be 10, it can be 100, whatever it may be. So the different value it can able to hold. Therefore, what type of data that a variable can hold is called as data type. Here, what is the data type? Integer is the data type. It indicates that the variable A is used to store an integer value. That's why this is called as a data type. Similarly, in the basic C programming, we have learned that we can use a float instead of int. For example, if I want to store some fraction, for like 14.10. Now 14.10 is not a whole number, it is a fraction now. Now instead of using int, I must use it as a float. So I need to use the keyword float now. So in the basics of C programming, we have already float, float. So we can use this keyword. It indicates that whatever the number we are going to store into the variable A, it is a floating type. Floating type means it contains fraction part also. Whole number as well as a fraction part it contains. Therefore, now the variable A is having this fraction with decimal point. Similarly, or I can able to store some characters. For example, shall take star. In the keyboard we are having star key. I want to store this star key into the variable A. Then what actually I am storing? I am storing a character. At that time, I need to call the integer A is storing character. Therefore, I need to write it as char. This char represent the variable A can able to store a character data. Actually, the ASCII value of star will be stored into the variable A. So this is how I can decide what are the different types of data that a variable can hold. So this is called as a data type. So different data types like char, int, s-bit. Here char is nothing but the character, this character. Float is not supported by our 8051. We will be having integer and we will be having character, and it may be signed as well as the unsigned. We know the difference between signed and unsigned that we have already discussed in the previous session. In case of unsigned number, unsigned means no sign. All the, for example, if I let us assume that 8 bits, it contains 8 bits now. This is the 0th bit, first bit, and so on up to 8 bit. Now all the 8 bit from here to here, all the 8 bits are reserved to represent the magnitude of a number. What is a magnitude? For example, 14. 14 is a magnitude. Or I want to represent 16. Now 16 is a magnitude without sign. Unsigned means no sign. So we call this as plus 16. Always it is a positive number. Whereas in case of signed character or a signed representation, signed data representation, the MSB bit is reserved to represent the sign of a number. This MSB bit, that is the most significant bit, is reserved to represent the sign of a number. For example, if this bit is equal to 0, then it indicates that this number is a positive number. So how many data bits are left now? Out of 8 bit, 1 bit is already reserved to represent the sign. Therefore, only 7 bits are left. So here you will be having only 7 bits from here to here. So only 7 bits are used to represent the magnitude of a number. So here this represents the magnitude of a number. Whereas in the earlier case, this represents the magnitude. Now 1 bit is reserved and only 7 bits are used to represent the magnitude. Otherwise, if this bit is equal to 1 instead of 0, if this bit is equal to 1, then that is a negative number, it is minus. If this is 1, then this number is a negative number. If this bit is 0, then this number is a positive number. So this is how we are going to decide whether the given number is signed number or the unsigned number, so that it is negative number or positive number respectively. Whereas the S bit is used to represent the single bit of the SFR register, and bit is used to represent the bit addressable memory. We know that in 8051 microcontroller, 16 bytes of memory will be reserved to represent the bit addressable data. So to represent bit addressable data, we are going to use the keyword or the data type called as bit in C programming. Whereas SFR is used to represent the SFR registers supported by 8051 microcontroller. So coming to this table, here this table represents what are the different data types, what are their size, description, data range, as well as the typical usage. Suppose if I represent a variable as a character, then how much bits are reserved? If it is integer, how much bits are reserved? Or for this type, what is the bit reserved in the memory location? We know that for the character type of data, it always reserves the 8 bits in the memory. It means that if you assign any character to a variable, then to store that character into the memory, 8 bits are used. It will convert that character into 8 bits and that will be stored in the memory. Now, what is the range of the characters that is supported? From what range it will going to support the character? So for that, we already know that depends on whether it is an unsigned number or it is a signed number. Means unsigned character or a signed character. Character always take 8 bits, whether it is unsigned or signed, whatever it may be. Now to find out the range, we must know whether it is unsigned or signed. We know that in case of unsigned number, all the 8 bits are used to represent the magnitude. See here, all the 8 bits are used to represent the magnitude. If it is unsigned, no bits are reserved, all are positive numbers only. So therefore, what is the data range now? The minimum possible number is 0 now. The minimum possible number is 0 because there is no negative number. All are positive. What is the minimum possible smallest positive number? That is 0 is the minimum possible positive number. And it can go up to 2 to the power of n minus 1. So where n is the number of bits, where n represents this number of bits. So in this case, number of bits are 8. Therefore, it is 0 to 2 to the power of 8 minus 1. Now, what is 2 to the power of 8? We know that 2 to the power of 8 is 256. 256 minus 1 is 255. Therefore, here the range will be from 0 to 255. So 0 to 255, totally how many data are available? Totally 256 data are available. Therefore, total number of data it can support is 2 to the power of 8, 256 data. And in case of X, it is 0 to FFH. Coming to the usage, it is usually used as a counter and a string of ASCII character, usually to store the ASCII characters. So whatever the keys which are there on the keyboard, all will be converted into equivalent ASCII character and that will be stored in the memory. That is how actually the characters will be stored. It can be any number, it can be any symbol, it can be alphabets, whatever it may be, all are taken as characters and that will be stored in the memory once it is converted into its equivalent ASCII value. Whereas in case of signed representation, we know that in case of signed representation, one bit is reserved to represent the sign. So that is called as MSU bit. So this bit is used to represent the sign of a number. Now now I can write either positive number or I can write negative number based on the sign of sign bit of a sign bit, whether it is 0 or 1. If it is 0, it is a positive number, and if it is 1, it is a negative number. So only 7 bits are used now to represent the magnitude. Earlier case we were using 8 bits, now we are using only the 7 bits. Therefore, the range will be from the possible minimum negative value is minus 2 to the power of n minus 1. This is the possible minimum negative number. Minus sign will be there because it represents both positive as well as the negative. Since we are considering the minimum negative number, that is minus 2 to the power of n minus 1. Why it is n minus 1? Out of 8 bits, 1 bit is reserved for sign. So how many bits are left now? Only 7 bits are left. Therefore, if I take the total number of bits as n, so how many bits we are using in this case? In case of signed representation, we are going to use 1 less than n, that is 8 minus 1, or nothing. In general, I can say it as n minus 1. Only n minus 1 bits are used to represent the magnitude of the number. Therefore, this is 2 to the power of n minus 1. Minus 2 to the power of n minus 1 to what is the maximum possible positive number? That is plus 2 to the power of n minus 1. Again minus 1 here. You first calculate what is 2 to the power of n minus 1. Once again subtract 1 from it. Suppose if I substitute 8 here, what is 8 minus 1? It is 7. 2 to the power of 7 is 128. That is minus 128. So it ranges from minus 128 to 2 to the power of n minus 1, which is nothing, plus 2 to the power of n minus 1. N is 8, 8 minus 1 is 7, 2 to the power of 7 is 128. 128 minus 1 again. So it is 127. You can observe here that in case of negative side it is 128, whereas in case of positive side it is 127. So this is because this positive number includes 0 also. It always includes, positive number always includes 0. So it is always from 0 to 127 in case of positive number, whereas in case of negative number it is minus 128 to minus 1. This is the range of the negative numbers and this is the range of the positive number. So if you totally count 0 to 127, totally it is 128. So that is nothing but 2 to the power of 8. 2 to the power of 8 is 2 to the power of 7 because n minus 1. So 2 to the power of 7 is 128. And this signed character is used to represent in the situation where positive and negative both the numbers are necessary to represent. For example, the temperature measurement, where the temperature may be either positive or the temperature may be negative. If I want to measure the temperature or if I want to read the temperature quantity, then I need to represent both positive as well as the negative. Similarly, we are having integer type. In case of integer data type, it is exactly double. It will going to reserve 16 bits to store any data. 16 bits are used to represent any data. Again, it may be two types, either unsigned or signed. Now you substitute this value here. For in case of unsigned, this is the formula. So we need to use this formula. So this formula we need to use if it is unsigned. And similarly, we use this formula if it is a signed number. Now it is unsigned number. I will use this number. I will use this formula. Therefore, 0 to 2 to the power of n. What is n here? N is 16. 2 to the power of 16 minus 1. I know 2 to the power of 16 is 65,536. 65,536 minus 1 is 65,535. 0 to 65,535. This is the range. And where we are going to use, coming to the applications or the usage, this is used to represent the 16-bit variables such as memory addresses. We know that memory is always a 16-bit address. So in case of to represent the memory address, we are going to use integer data type. And to set the counter value more than 256, more than or equal to 256, we are going to use integer data type. In case of character data type, what is the range? 0 to 255. For example, if I want to store the number 300, let us assume that I want to store variable y is equal to 300. Now, if you declare the variable y as a char, suppose if I declare the variable y as a char, that is nothing but char space y is equal to 300. If I declare like this, then this is a wrong, because you cannot able to store 300 number into the y, because what is the limit of the character? Limit of the character is that y can take maximum value of 255. After 255, again if you increase it by one value, then automatically it becomes 0. Now you cannot declare this as char, it is wrong. Then if I want to store the number more than 256, 255, 256, 257 or any number up to 65,535, then you must declare it as an integer. If you declare it as an integer, then the number can be, the larger number can be stored into that particular variable. Similarly, we are having signed int. In case of signed int, it represents both positive as well as a negative number. One bit is reserved. Therefore, I will substitute 16 here. 16 minus 1 is 15. 2 to the power of 15, it is 32,768. Minus 32,768 to this is 32,768 minus 1. That is 32,767. And again S bit, that is nothing but the single bit. This is used to represent SFR bit addressable only. We know that in case of SFR registers, some of the SFR registers are bit addressable, whereas some other SFRs are only byte addressable. For example, if I take the ports, all the ports are bit addressable. So many of the SFRs are bit addressable. Now, if I want to define or if I want to declare one particular bit of the SFR register, then I must define or I must declare that variable as a S bit. So S bit is nothing but the single bit to represent one bit. Similarly, I am having another data type that is called as bit. So this is used to represent the bit addressable RAM. So we know the range of the bit addressable RAM will be from 20H to 2FH. Now to represent this bit addressable memory location or to represent any bit in the bit addressable memory location, its memory location actually, we are going to use the keyword or we are going to use the data type called as bit to access bits of bit addressable memory space. Similarly, you can have, and coming to the size, it can take only 1 bit size, whereas this also will going to reserve only 1 bit. Whereas SFR, that is a special function register, it assigns 8 bits or it reserves 8 bits. And we know the address of the SFR range, that is from 80 to FFH. In this range, SFRs are available. Not in all the locations, only in some of the locations SFRs are available. That we have already seen in the memory organization of RAM in the previous class in the chapter 1. To access the byte size SFR registers. So all the SFR registers are byte accessible, but only some of the SFR registers are bit accessible along with the byte accessible. Now, if I want to access all the bits, that is nothing but 1 byte, 8 bits of data, then I can declare that that with the keyword SFR. So these are the different types of data types supported by 8051 C programming. Then coming to the general structure of embedded C. So what is the structure? How to write the C program? We already know how to write the C programming in the earlier semester. We have written and we have done many experiments with the C programming. So the first statement is always a hash include reg51.h. Okay, so this is called as a preprocessor directive, hash include. So what this will do, this preprocessor directive will going to include this header file. .h is the header file, reg51. The library file reg51h contains the definition of all the special function registers and their bits. So all the definition of the registers, special function registers, everything will be defined in this header file or in the library file. So if I want to use any of the registers, any of the ports, internally port it is also having some register. Each port is having its own register internally. If I want to access those registers, then I must know its definition. So all these definitions will be available in the header file reg51.h. In the normal C programming, we are going to use hash include stdio.h or hash include math.h or conio.h. We are going to use stdio for the standard input output. For example, if I want to use the printf function and the scanf function, then I must include the header file stdio.h, that is standard input output header file I must include. Similar, because the definition of or the function called function definition of the printf, scanf, all these are available in the stdio.h. In the same way, the definition of all the registers available in 8051 are defined in register 51.h header file. And a list of global variable declaration. If any global variables are there, global variable means these variables can be accessed by any of the functions, including main function. So such variables are called as global variables, and global variables are always declared out of the main function. A list of subroutines used in the program. What are the different types of subroutines? In C programming, we call this as functions, whereas here in assembly language program or in 8051 C programming, we call this as subroutine. So subroutine is a separate program which is used to perform some repeated task. So if we are having some subroutines in our program, then we need to define its prototype, or we need to define its definition. We need to define its definition before the main function. So after the declaration of these two, then we are going to define a main function. Main function with local variable declaration. Inside the main function, you can able to declare any variable. So if you are having main function, so for example, if I write void main, or simply if I write main function, and inside the main function, so here you are having some statements of the C program. So here what do we do? In this area, we are going to declare the variables that are used by this program. Suppose if I want to declare a int a, or I want to declare char b, or s bit p1.2, x is equal to p1.2. If I declare these declaration, then these variables can be accessed by the program used here. So this is nothing but the program. Some statements are there. And main body of the program within the flower brackets. So this main body, this is called as body of the program. So this must be enclosed between two brackets. So here we are going to use these two brackets, opening as well as the closing bracket. So inside these two brackets, flower bracket, all the statements should be written. The last line is coded as while one. Since one is true, while one loop will never terminate. In case of assembly language program, we have used the statement, or we have used the mnemonic like SJMP here. So after all the statements are executed, or all the instructions are executed, last instruction what we are going to write is SJMP here. So where the here label will be written in the same line, so that it will infinitely execute the same statement again and again. In the same way, in case of C programming, we are going to write while one along with a semicolon. While one means it is always true, so this will be executed infinite number of times repeatedly. So coming to the example of the structure of the C programming, so you can observe here, this is how the C programming can be written. So here hash include reg51.h is there, and this global variables as well as the subroutine is not defined here, because it doesn't use any global variable, or it will not use any subroutines, any subprograms is not there. Then we are having main function. So this is the main function, void main. Void means return type is nothing. So after the execution of this program, it will not return anything to the operating system. Usually the calling function for the main function is the operating system. After the execution of this program, it will not return anything into the operating system. And then we have main body of the program. Before that, we need to declare some local variables. You can observe this is the local variable unsigned char I. So this variable I can be used only within the main function. Within this open bracket to close bracket, I can use only the variable I. That's why this variable is called as a local variable. Whereas if you declare any variable here in this area, then whatever the variable you are going to declare here, that can be used by any other function, including main function. You can use the same variable here. For example, if I declare unsigned char j, then j can be used here without defining j here, because j is a global variable which can be accessed by any of the function. I can access this with the main function, or I can access this with the function 1. Suppose I am having one more function, ಬೇರೆ ಇನ್ನೊಂದು ಏನಾದ್ರು ಫಂಕ್ಷನ್ ಇದ್ದರೆ, ಬೇರೆ ಇನ್ನೊಂದು ಫಂಕ್ಷನ್ ಏನಾದರೂ ಬರೆದಿದ್ರೆ ಇಲ್ಲಿ, then I can access this global variable. Suppose if I would have written ಬರೆದಿದ್ರೆ ಏನಾದರೂ global variable, then I can use then function 1 can also access this variable. And then we are having the last line is while 1. You can observe here, this is the while 1. These are the statements of the C program. Then at the end, the while 1 command is executed, statement is executed infinite number of times. So this example is used to store write a C program to display the value from 00 to 10h to the port 0 only once. So what we need to do, we need to write a program. So this program has to display 00 and 10, 00 to 10. That is named 0001, 02, 03 and so on up to 10 to the port 0 only one time. So what I will do now, I will declare a header file reg51.h #info and void main. Void main means it will not return anything after the execution. So this is the main function, and there should not be any semicolon here because it is a called function. And open the bracket. Then unsigned char I. I am going to declare one variable I, which is of type unsigned character. We know that if I declare the variable as a character, then 8 bits are reserved to store some number into the variable I, and it is of type unsigned. There is no sign. So the range will be from 0 to 255. And I am using the for loop for I is equal to 0, I less than 10, I plus plus. The value from 0 to 1h will be displayed here. So in case of C programming, instead of writing 1h hexadecimal, we are going to use 0x. So this 0x stands for the number, whatever we are going to have here, that is an hexadecimal number. Therefore, it will going to display the number from 0 to 10. And there is no semicolon here again. Next, it will be repeated. So again, for the for loop, we need to write the open brace as well as close brace that we need to write. But suppose if you are having only one statement in the for loop, then it is not necessary to write the open brace as well as the closing brace. Suppose inside the for loop, if you are having two statements, ನಿಮ್ಗೆ ಏನಾರು ಎರಡಿದ್ರೆ p0 ಅಂತ ಒಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಇದೆ, p1 is equal to I ಅಂತ ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. ಅವಾಗ ಎರಡು ಸ್ಟೇಟ್ಮೆಂಟ್ ಇದೆ. ಎರಡು ಸ್ಟೇಟ್ಮೆಂಟ್ ಇದ್ದಾಗ ಏನು ಮಾಡಬೇಕು, ಫಾರ್ ಲೂಪಿಗೂ ಕೂಡ ಬ್ರೇಸ್ನ ಓಪನ್ ಮಾಡಬೇಕು ಮತ್ತು ಬ್ರೇಸ್ನ ಕ್ಲೋಸ್ ಮಾಡಬೇಕು. ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಫ್ಲವರ್ ಬ್ರಾಕೆಟ್ ಬ್ರೇಸ್ ಓಪನ್ ಮತ್ತು ಕ್ಲೋಸ್ ಮಾಡಬೇಕು. ಒಂದೇ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇದ್ದಾಗ ಬ್ರೇಸ್ನ ಯೂಸ್ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಹೇಗೆ ವರ್ಕ್ ಆಗುತ್ತಿದ್ದು, ಫಾರ್ I is equal to 0, I less than 10, I plus plus. ಇಟ್ ವಿಲ್ ಚೆಕ್ ದ ಇಟ್ ವಿಲ್ ಡೂ ದ ಇನಿಷಿಯಲೈಸೇಷನ್ ಫಸ್ಟ್. ಏನು ಮಾಡುತ್ತೆ, ಐನ 0 ಮಾಡ್ಕೊಳುತ್ತೆ. I 10ಗಿಂತ ಚಿಕ್ಕದಿದೆಯಾ ನೋಡ್ಕೊಳುತ್ತೆ. ನಾವು I is equal to 0, ಡೆಫಿನೆಟ್ಲಿ I is less than 10. 0 is less than 10, yes. If this is true, this is called as condition. Initialization, condition and increment or decrement. So this is the initialization and this condition is true. Initial I is equal to 0. So 0 is less than 10. This is true. So come here. P0 is equal to I. What is I now? I is equal to 0. So 0 will be displayed on the port 0. Once again it will come back to for loop. Now I has been incremented. I plus plus. I is incremented to one time. Now I becomes 1. So I is equal to 1 now. Now again check this condition. Is 1 less than 10? Yes. Again come here. Then P0 is equal to I. Now in this case I is equal to 1. Again increment I by 1 time. So I is equal to 2 now. Once again come here. 2 less than 10. Yes. Once again execute. Display 2 into the port 2. P0 is equal to I. I is equal to 2 now. So 2 will be sent to port 0. So this for loop is repeated for 10 times. For 10 times it will repeat. Values from 0 to 1h will be displayed. Now we have used less than. Less than condition we have used, so it will display the value from 0 to 9. Suppose if I want to display the value 10 also, then what I will do, less than or equal to symbol I need to use. For I is equal to 0, I less than. For example, at some point of time I becomes 9 ಆಯ್ತು ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. ಲೆಸ್ than ಮಾತ್ರ ಇದೆ. Now 9 less than 10 it will check. 9 less than 10. Yes, this condition is true. Therefore, again this will be displayed. It will enter into inside the for loop and it will display this 10 value. And again after 9, what do you get? You will be having A. Again check the condition. A is less than 10h. That is hexadecimal 10 it is. Yes, definitely A is less than 10. Again B, C, D, E, F. After F you are going to get 10 again. After F the next number is 10. And then again it will check the condition 10 less than 10. Now 10 less than 10 is false. Therefore it will not go and execute this command. It will come out of the for loop. It will come here and it will execute the while one function along with a semicolon. Since semicolon is there, the same statement is executed infinite number of times. So therefore 10 less than 10 is not true. Therefore the number 10 will not be displayed here. Suppose if I want to display the number 10, ಈ ಥರ ಲೆಸ್ ದ್ಯಾನ್ ಕಂಡೀಷನ್ ಕೊಟ್ಟರೆ ಏನಾಗುತ್ತೆ, 10 ಅನ್ನೋ ನಂಬರ್ ಡಿಸ್ಪ್ಲೇ ಆಗಲ್ಲ ಪೋರ್ಟ್ 0ದಲ್ಲಿ. ಅದಕ್ಕೆ ನಾವೇನು ಮಾಡಬೇಕು, ಲೆಸ್ ದ್ಯಾನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಕಂಡೀಷನ್ ಕೊಡಬೇಕು. ಲೆಸ್ ದ್ಯಾನ್ ಆರ್ ಈಕ್ವಲ್. ಸೊ ಹಿಯರ್ ಇಟ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ ಆರ್ ಈಕ್ವಲ್. ದೆನ್ ವಾಟ್ ಇಟ್ ವಿಲ್ ಡು, if 10 is less than 10 or if 10 is equal to 10. Now the second condition is true. 10 is equal to 10. If 10 is equal to 10, yes, this condition is true. Once again come here, P0 is equal to I. What is I now? I is equal to 10. Therefore 10 will be displayed here. Again for the next case, I is incremented. Now this becomes 11. Now it will check the condition 11 less than or equal to 10. If this condition is true, 11 is neither less than 10 nor equal to 10. Therefore this condition is false. This condition is false. So if the condition is false, don't go inside, come out of the for loop. It will directly execute the next statement, that is while statement. It will execute. So therefore this will be repeated for infinite number of times. So it is given in the for statement, I less than 0x 10 0 implies that I less than 10h. So 10h in C programming we write it as 0x. 0x stands for it is an hexadecimal data. This number is a hexadecimal data. Suppose if I don't write 0x here, 0x bardilla bari 10 bardre enagutte, then it will be taken as a decimal number and automatically it will be converted into hexadecimal. We know decimal 10 is equal to A in hexadecimal. Therefore this will be automatically taken as A. A is nothing but 10 in decimal. Hexadecimal A is 10 in decimal. Then we shall see the second example. Write an 8051 C program to display the value from 0 to 10 repeatedly to the port 0. So earlier was port 0 to 10 only, but only once. Now it is repeatedly. Infinite number of times we need to repeat this. So what do we do now? Same thing, define the header file hash include and then void main unsigned char I. I will declare one variable I. Then while 1, I will put everything inside the while 1. So we know that while 1 is always true. So therefore this will be repeated infinite number of times. Again for I is equal to 0, I less than or equal, I will use the symbol I less than or equal to 10 I plus plus. So that 0 to 10 h, because 0x is there, 0 to 10 h will be displayed on the port 0. Every time each number will be displayed. Initially 0 will be displayed and then 1 will be displayed, 2, 3, 4 and so on up to 10h will be displayed. After displaying 10h, once again it will come back here while 1. Once again after 10h, again it will make I is equal to 0. So after 10, again it starts from 0. It will not display 11. It will start from 0 again 0 to 10. Again it will come back, again it will display. So like this, it will be repeated. These two statements will be repeated for infinite number of times because of this while loop. So it will go inside and it will check this condition and it will repeat the task, and there is no semicolon here. So if I add semicolon here, then what will happen? It will not go inside the while loop. It will keep executing only this statement. Like that of the earlier case, you see, semicolon is there because there is no statement after the while. I want to make my microcontroller to execute this statement only continuously, infinite number of times. So semicolon always indicates it is an executable statement, whereas here no semicolon is there. Therefore, if the condition is true, go inside the loop or come out of the loop. So this is this is inside the loop and this is out of the loop. It will directly come here. It directly comes here. It will execute any instruction if it is available in this area, and then it will end the main. So in this case, we need to repeat this task continuously. Therefore, I will write while one. So while one is always true. Continuously, you execute these two statements infinite number of times. So this is the closing brace for this opening brace, and this is the closing brace for the main function. This is the closing and opening brace for the while loop. This is a loop, while, for, do while. All these are the examples of the loops in C program. Then example 3, write an 8051 C program to toggle all the bits of P2 continuously. Toggling means what? Toggling means making it as exactly ulta, like negative, negation. For example, if the bit is 0 1 0 1 1 1 0 0, then what is the toggle of this one? You make everything reverse, exactly opposite, not operation. Make 0 as 1 and make 1 as 0. Again this is 1 0. Again this is 0 0 and this is 1 1. Therefore these two are toggle to each other, exactly complement. So C program to toggle all the bits of P2, 4 to 2 bits continuously. Continuously means again it is infinite number of times. Therefore what I will do, void main while one infinite number of times. I need to repeat this task. Initially we will make P2 is equal to 0x55 and then its toggling value. What is 55 in 55 hexadecimal? In decimal, how do you write? How to decide 55 is decimal or hexadecimal? Because 0x is there. 0x stands for this number is a hexadecimal number. And what is the equivalent binary number for the hexadecimal 5? That is nothing but 0101 is 5. Again it is 0101. Now I will toggle this one. I will take the complement. What is the complement of 1? Complement of 0 is 1. Complement of 1 is 0. This is 1 0 1 0 and this is 1 0. This is the complement. And what is its equivalent x value? This is nothing but a and this is nothing but a. Therefore the complement of 55 is a. So initially I will send 55 into the port 2 and then I will want to send its complement value AA. How many times? It is for infinite number of times. So therefore this will be executed infinitely. AA again 55, again AA, again 55. It will be repeated for infinite number of times. Next, write an 8051 C program to toggle the pin P2.3 500 times. Now here they have given the condition. We need to toggle P2.3. Now P2.3 is what? Third bit of the 4 to 2. Only one bit it is. Only single bit. Single bit can take only two states. Either the bit can be 1 or the bit can be 0. Only two states are possible for the single bit. And it is given that we need to toggle this 0 to 1, 1 to 0, 0 to 1. We need to switch this for how many times? 500 times. What I will do now? Hash include reg51.h and then I will going to define one bit that is called as S bit. We know that S bit is nothing but the single bit which is used to define or declare a variable which can hold only single bit of a SFR register. I know that P2 is a SFR register, 4 to 2. All the ports are SFRs, special function registers. and I'm taking only the third pin of the port to 2, and this is assigned, this is defined to output pin. Therefore, the status of pin P2.3 is same as that of reading the variable out pin. Now I am assigning P2.3 as out pin. So inside the program, instead of accessing P2.3 every time, you give one name here, that is out pin name. ನಾವು ಪ್ರತಿ ಸಲ P2.3 P2.3 ಅಂತ ಆಕ್ಸೆಸ್ ಮಾಡೋ ಬದಲು ಅದಕ್ಕೊಂದು ನೇಮ್ ಕೊಡ್ತೀವಿ. ಈ ನೇಮ್ನ ಯೂಸ್ ಮಾಡಿಬಿಟ್ಟು P2.3 ಪಿನ್ನ ಆಕ್ಸೆಸ್ ಮಾಡ್ಬೋದು. So this is the declaration or the definition of this one port P2.3. Then void main, open the brace, unsigned int. I will define one variable I of type integer. Again, for I is equal to 0, I less than 500, I plus plus. Why I need to declare this as integer? In the earlier case, we have declared these things as character, unsigned char I. This is the reason because that here in case of condition, what is the maximum number we have taken? 10 is the maximum number. If I use a character data type, then what is the maximum value that I can take? It is from 0 to 255. So I can take the number, it can count the number from 0 to 255. Whereas here in the question it is given that we need to toggle this for 500 times. Now more than 255 I cannot able to declare with the character. Therefore I will take integer as the data type. Now I is a variable of type integer. Therefore I can check its condition until it becomes 500. Now they have given 500 times. 500 times means always it starts from 0. From 0 to 499 times. So 0 to 499 times, total it is 500. So total count will be 500 times. Therefore for I is equal to 0, I less than 500, I plus plus. Initially make I is equal to 0. Definitely 0 is less than 500. Come here. Out pin is equal to 0. What is out pin? That is in the word P2.3. Therefore P2.3 becomes 0. Again make out pin is equal to 1. ಮೊದಲನೇ ಸಲ P2.3 0 ಮಾಡಿ ಮತ್ತೆ P2.3 ನ 1 ಮಾಡ್ತೀವಿ. For example, shall assume that this is our 8051 microcontroller, MC 8051 microcontroller, and this pin is P2.3. Suppose this pin is connected to an LED. Shall assume that an LED is connected here and another end of the LED is connected to ground. This is the light emitting diode. So shall assume that this is an LED. So what will happen now? It will start glowing as soon as this becomes 1. Initially output is equal to 0. LED is in the off condition. Again make output is equal to 1. LED is turned on one time. Again come back here. I is incremented by one time. Initially I was 1. Now I becomes, initially I was 0. Now I becomes 1. Now again check this condition. Is 1 less than 500? Yes. Again come here. Again make it as 0. LED off. Again make 1. LED on. Once again come here. Make I is equal to I plus 1. I plus plus is nothing but I plus 1. That is I becomes 2 now. Again compare. 2 is 2 less than 500? Yes. Again come here. Again execute. So this will be repeated for how many times? Until I becomes 499. So when this is repeated for 499 times, 499, it will check the condition. When I is equal to 499, at certain point of time, the value of I becomes 499. Again check this condition. Is 499 less than 500? Yes. Once again execute this two. Again increment I value. Then now I becomes 500. Now for the next case, when I is equal to 500, I 500 adaga, check the condition. Is 500 less than 500? No, this condition is false now. 500 is not less than 500. 500 is equal to 500. Since this condition is false, it will not go inside. Idu condition false ಆದರೆ ಇದು ಒಳಗಡೆ ಬರಲ್ಲ, ಬ್ರೇಸ್ ಇಂದ ಒಳಗೆ ಬರಲ್ಲ. It will exit. ಫಾರ್ ಲೂಪ್ ಇಂದ ಹೊರಗಡೆ ಬಂದ್ಬಿಡುತ್ತೆ. ಫಾರ್ ಲೂಪ್ ಇಂದ ಹೊರಗಡೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಓಪನ್ ಆಗಿದೆ, ಇಲ್ಲಿ ಕ್ಲೋಸ್ ಆಗಿದೆ ಫಾರ್ ಲೂಪ್. ಇದರಿಂದ ಹೊರಗಡೆ ಬರಬೇಕು. So it will directly come out of this one and it will execute the next statement after the closing brace of the for loop. What is the next statement we are having? While one. Therefore repeat this task for infinite number of times. Only this statement is executed for infinite number of times. This is just like a idle condition of the microcontroller. So one more program we shall see. Write an 8051C program to send the values -2, 3, 1, -5 to the port 1. So for this, what is required now? Array is required. So one dimensional array we are going to use. Array is nothing but a group of characters. So here in this group we are having some characters, negative and positive characters. So I am going to declare one array along with a square bracket. I don't know the size. So exactly here 4 data are there. You can declare this as a 3 because it starts from 0 to array always index with 0 to n-1. n is the total number of data available. So how many data are available here? 4 data are available. 0 to 3 it is. So 0 to 3 totally how many values are there? 0, 1, 2, 3. Totally 4 values are there. ಸೊ ಇಲ್ಲೇನು ಮಾಡಿದ್ದೀವಿ, ಚಾರ್ ಅಂತ ಡಿಕ್ಲೇರ್ ಮಾಡಿದ್ದೀವಿ, ಅದಕ್ಕೊಂದು ನೇಮ್ ಕೊಟ್ಟಿದ್ದೀವಿ ಔಟ್ ಅರ್ರೇ ಅಂತ ಅಂದ್ಬಿಟ್ಟು. ಸೈಜ್ ಗೊತ್ತಿದೆ, ಇದ್ರೊಳಗೆ ಬರೀಬೋದು. ಎಷ್ಟು ವ್ಯಾಲ್ಯೂಸ್ ಇದೆ ಇಲ್ಲಿ? 4 ಇದೆ. 4 ಇದ್ದಾಗ 3 ಅಂತ ಬರೀಬೇಕು. 3 ಅಂತ ಯಾಕೆ ಬರೀಬೇಕು? ಬಿಕಾಸ್ ಇಟ್ ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ 0. ಔಟ್ ಅರ್ರೇ 0ದಲ್ಲಿ -2 ಇರುತ್ತೆ, ಔಟ್ ಅರ್ರೇ 1ನಲ್ಲಿ 3 ಇರುತ್ತೆ, ಔಟ್ ಅರ್ರೇ 2ನಲ್ಲಿ 1 ಇರುತ್ತೆ, ಅದೇ ಥರ ಔಟ್ ಅರ್ರೇ 3ನಲ್ಲಿ -5 ಇರುತ್ತೆ. In the memory, all these data will be stored in the array memory. And then unsigned char I will declare one variable I. Then for I is equal to 0, I less than for I plus plus. P1 is equal to out array of I. Initially what is I? I is equal to 0. Check the condition. Is 0 less than for yes. Come here, out array of 0. What is I now? I is equal to 0. Initially I is equal to 0. Therefore 0. Out array of 0. What is out array of 0? That is nothing but -2. Take the -2 data and send it to port 1. Once again come here. I plus plus. I becomes what now? I becomes 1. Again check the condition. Is 1 less than 4? Yes. Again come here. Out array of 1. What is out array of 1? That is nothing but out array of 0 is -2. Out array of 1 is 3. Take this 3 here. 3 is sent to port 1. Again increment I value by 1 time. Now I becomes 2. 2 less than 4 is true. Once again you come here. Out array of 2, which is nothing but array of 2 is +1. Send +1 to P1. Again I is incremented by 1. I becomes 3. 3 less than 4 is true. Once again come here. Out array of 3, which is nothing but 5. -5. -5 will be displayed. Now I becomes 4. Again now check the condition. Is 4 less than 4? No, this condition is false now. Then it will exit the for loop. Exit the for loop means I told you you are having only one statement. It is not necessary to write the brace. ಬ್ರೇಸ್ ಬೇಕಾದರೆ ಬರ್ಕೋಬೋದು. ಯೂಶಲಿ ಒಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ಗಿಂತ ಜಾಸ್ತಿ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇದ್ದರೆ ಬ್ರೇಸ್ ಬರಿತೀವಿ. ಒಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ಗಿಂತ ಜಾಸ್ತಿ ಇದ್ದು ಬ್ರೇಸ್ ಬರ್ದಿಲ್ಲ ಅಂತಂದರೆ ಇಟ್ ವಿಲ್ ಟೇಕ್ ಎಕ್ಸಿಕ್ಯೂಟ್ ಓನ್ಲಿ ದ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ವಾಟ್ ಈಸ್ ರಿಟರ್ನ್. ಓಕೆ, ಕಮ್ ಔಟ್ ಆಫ್ ದಿಸ್ ಫಾರ್ ಲೂಪ್ ಬಿಕಾಸ್ ದಿಸ್ ಕಂಡೀಷನ್ ಈಸ್ ಫಾಲ್ಸ್, ದೆನ್ ಎಕ್ಸಿಕ್ಯೂಟ್ while 1. So it is nothing but the infinite loop. So this is how we can able to display these numbers into the port 1. So coming to the summary of this session. In this session we have learnt how to do the programming with C. Introduction, advantages, disadvantages, what are the different data types supported by 8051C programming, as well as the general structure of C programming and some of the sample programs by using C. Thank you.